Okay, so let's look at our problem with concerning dilation and the scale factor. So this is the scenario that we have. It says an office supply store sells index cards in two different sizes. The large size is a dilation of the small size. Both sizes are shown right in this area on our coordinate plane. So we have, and it says find the scale factor of the dilation. So we first need to identify what is our pre-image and which one is our image. Okay, so the pre-image is the original figure with the original dimensions. So this is going to be our pre-image, and the larger one is going to be our image. Okay, so you may be asking, how do I know that? Well, it tells us as two ways. It says here first, it says the large size is a dilation. In other words, the large size has been dilated from the small size. So we started with the small size and we dilate or we enlarge to the larger size. Also, the other way that you can tell is for the pre-image, we have rectangle PQRS, and for the image after the dilation, we have P prime, Q prime, R prime, and S prime. So this is not an apostrophe. This is actually the prime notation. So that tells us that we start with this pre-image and then we actually dilate and enlarge. This is an enlargement. Okay, so we're going from a smaller image to a larger image. And so what we need to use is a ratio of the dimensions for our image over our pre-image. So for the scale factor, and I'll just write it here so we'll have it. So for the scale factor, we have a ratio of the rectangle P prime, Q prime, R prime, S prime over the rectangle of P, Q, R, S. Okay, so we're going to use this ratio to determine what is the scale factor of the dilation. So because this is a rectangle, we know that this QP and RS, both of those sides are equal, and PS and QR are also equal. So we'll only need to look at the units between P and S for our length and Q and P for our width. Okay, so but because we're starting with, we must start with our numerator with our P prime, Q prime, R prime, S prime. We're going to look at the units for the larger or the image from the dilation. So we have we will start with, let's do P prime, Q prime over, let me get my prime there, over P, Q. So we want to count the actual units just like we did with Pythagorean theorem, and we wanted to find the sides of A and B. We counted the units between points. So we're going to count the units between P and Q for the width and P and S for the length. So let's start with the width. So we start here and we're going to count every time we actually move. So we have 1, 2, 3, 4, 5, 6. So our P prime, Q prime is 6. The unit number is 6. Now we're going to finish our ratio, and it'll be 6 over our PQ. So we go to our pre-image and we count between units. We count the units between P and Q. So we start with P and we count as we move. 1, 2. So, and because it's a fraction, we always want to make sure we reduce the fraction to its lowest terms. So 6 divided by 2 is 3. So now we're proposing that the scale factor is equal to 3. But let's look at the other dimension. So we looked at the width for both P prime, Q prime, and we also did it for P and Q. Now we want to look at the scale factor for our PS, P prime, S prime, excuse me, and our P and our S. So we have P prime, S prime as a ratio over P and S. So now we're going to count the units between P prime and S prime, and we're going to have that over, or put that over our PS units. So let's start with P prime, S prime. So we start here, and we're going to count the units to here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the units for our P prime, S prime is 9. Now we're going to do the same thing for our pre-image and the line segment PS. So we start with P, and we're going to count the units to S, and we only count when we move. So we start at P, and we count 1, 2, and 3. And again, it's a fraction, so we want to reduce it to its lowest terms. 9 divided by 3 is 3. So both dimensions of our pre-image and image has a scale factor of 3. So that means that, yes, this is our scale factor. And that's it.